Okay, similarly to the inverse sine function, the inverse cosine function is not one-to-one, so we need to restrict to a portion of it that is one-to-one, and then we can swap x and y and denote what the inverse is and that sort of thing. And what we're going to do with inverse cosine is we're going to pick the piece of the graph containing the full range of cosine, but a restricted domain of cosine. So we'll pick the interval from 0 to pi and the y values from -1 to 1 represent the entire range of cosine. Now what we're going to do is when we swap x and y, we obtain a statement that is the formula x equals cosine of y. Okay, so it seems simple enough compared to what we've done before with inverses. We will denote this formula as either arc cosine of x, which is accepted widely in WebAssign, or you may see in your ebook cosine inverse of x. Okay, so what we mean is the following. If cosine of an angle is a number in the interval -1 to 1, then inverse cosine of a number in between -1 and +1 will be an angle in only the designated interval that we've chosen to make the piece 1 to 1. Okay, so that is why the inverse trig functions themselves are not periodic, because basically what you see, and to the right here is what you see is what you get. So we had points on the original graph like 0, 1, which becomes 1, 0 on the graph of the inverse. We had pi over 2, comma 0, which becomes 0, pi over 2. We had pi, -1, which becomes -1 pi. And if I really wanted to be careful and alert with what I'm doing, I could say, okay, pick a pi over 4 guy. All right, cosine of pi over 4 is 1 over root 2, or root 2 over 2. So I would come over here, root 2 over 2, which is about 0.71, would be associated with the angle pi over 4. Okay, so those same reference angle guidelines will be met. Now, again, it takes a little practice. It feels counterintuitive until you get used to it. But you have to remember that you're taking a function that isn't one-to-one, using its entire range to get a representative, and then swapping the x and y values for the representative. So it will really help you to know the window that you're operating in for the original function. And I would suggest going ahead and listing, and let me make sure you're not confused by that. Pi over 2 is the guy right here. I would list all the special angles in this window, pi over 6, pi over 3, and then come in the, basically the, second quadrant, list the ones that you know, and then go back over here and find them on the scale for arc cosine. Okay?